All right. So welcome everybody. Today is January 9th, 2025. Happy New Year. Um, Today we have one topic about DRA, the updates from DRA. However, I wanted also to mention that there was mm, a couple of people from, I believe, IBM that wanted to discuss a proposal they have for a cap regarding topological um, scheduling or topology aware scheduling. However, we discussed this offline, and I directed them to present in working group batch first, because this is touching on the proposal is touching on multiple things such as pod groups and of course hierarchical or topological scheduling for pod groups, which is something that is already implemented in Q. So I wanted to make sure that the Q team is aware and that whatever is proposed for the scheduler is not in conflict and is also potentially usable, as opposed to never be reconciled. So, or them being alternative implementation. So it's going to go to working group batch first. I believe it is probably already in the agenda for the next meeting. So if you're interested in this topic, please attend working group batch. And yeah, with that, I think we can move to John.
Okay.
Yeah. Do you need to present anything?
No, I don't think. Well, I can. I mean, it's just the agenda, and then if we click through to some of the issues if we want. But I just wanted to raise the awareness here, and we're probably going to need some of these opted in by the SIG scheduling leads. Um, so there's a few different things we're working on in 133 for DRA. Um, Only one thing is a beta. We went to beta. We went to beta with the base cap last cycle, and we intend to stay in beta this cycle. I I have a somewhat lofty goal to get to GA in 134. It's it's aggressive. We'll see if that's feasible. Uh, but so 133 is going to be about figuring out, nailing down any groundwork for that. Um, there's another networking related thing that's going to go to beta, but that doesn't matter to this group. And the rest of these things listed here are all alpha or pre-alpha type of discussions, but I wanted to raise them here. One is we have this idea of partitionable devices. So this is a way to break partitions down into break individual devices down into smaller partitions in some cases, but it actually can be used to create, like in the TPU case, you can have a node that's got 8 TPUs, and you can use all 8 for a pod, or you can use 2 for a pod. But if you use 2, there's only certain combinations of 2 that are valid. So that actually is supported by this, and actually it extends beyond that to multi-node resources. So the relevance here, it's actually owned by Signode, but as I look at it and think about it, it's probably mostly touching scheduling components. So um,
Mhm.
we certainly will want a lot of your input. If not, maybe it even belongs in SIG scheduling. We did that with another cap, which I'll bring up after this one in the past. But really, this is about how we account for resources on a device, uh, rather on a node. Um, uh, it doesn't have that much to do with what kubelet does to talk to the DRA driver.
Um, One question so far. So when you said, did you say multi-node
Yeah,
devices?
yeah,
So is that a device that can be accessed by different nodes?
yes.
Or is it a
So
device that is partitioned across multiple nodes?
yes, yes, and yes. Okay, so the most interesting use case, there's a couple of use cases for the multi-node non-partitionable. Okay, we already have that. Like one way that, for example, NVIDIA is going to use that is we have this idea of an IMEX channel. So it's just a resource, a logical, essentially a logical resource, but like a sort of configuration piece resource that gets shared across different GPUs to segment them into groups. And so you would assign to different pods, they would attach to that individual IMEX channel, which would be represented by a resource claim. That IMEX channel is only accessible by nodes within a given NVLink domain. And so pods that so the idea is this for security. So you could have a namespace, you create an IMEX channel, which is a resource. That resource is accessible by any node in that NVLink domain. But of course, since it's a namespace resource, it's accessible only by pods that are in the same namespace. And so you've now created a namespaced segmentation of the NVLink domain. So that's how NVIDIA wants to use a multi-node resource, nothing to do with partitionable. Now, at Google, we have this concept of TPU slices, we call them, which are multi-node. Like each node has maybe 8 TPUs in it, but you can there's a interchip interconnect fabric between those chips on all the different nodes, and so you can have like a say a 16 node block, we call it a TPU slice, or say a 64 node TPU slice. That's the largest we allow right now. But you can subdivide that. Like if you want, you can use you can provision the whole 64 node um, um, TPU slice, and then you can say, but I want to pull a four node segment out of it. And so this actually, from a logical structure point of view, looks exactly like I have a GPU, and I want to pull out a piece of it as a MIG. And so because that 4x4 means I can no longer do, or that 4 node one means I can no longer do an 8 node one that includes those same nodes, right? So it has the same structural from a scheduling and a sort of a logical organization point of view. So so we plan to use this. If you imagine that 64 node block, if one of those nodes fails, well, you can't use the whole 64 node one, but you can use all those sub slices still. And so today, with the way we do it in Kubernetes today, basically, if one of those nodes fails, you have to provision another 64 nodes, which is obviously extraordinarily expensive and painful. So the idea is that now you'd be able to still make use of the 63 other nodes. And we have a way to model that in a multi-node partitionable resource by attaching a node label to each partition, which identifies the set of nodes that are part of that partition. So this effectively becomes a dynamically scheduled label selector. So you make a resource claim against um, against uh, a TPU subslice, and the scheduler, when it goes and schedules the first pod to that claim, will hit the DRA functionality, which will pick a node for that pod, which in order to do that has to pick one of those subslices. And now that node selector associated with that partition, that 4 node partition, gets copied into the resource claim. So the next pod that comes along that uses that same resource claim is constrained to that node selector. But you didn't have to know that ahead of time as a user. You didn't have to say, I want this particular subslice. You just say, I want one of this size, and we'll select it out of that whole thing and dynamically, effectively apply a label selector to your subsequent scheduled pods. So it's actually pretty cool. But you can see it's all scheduling. Like what does Kubelet have to do with any of that? Nothing. So
Yep.
in that sense, I wonder if we should move it to SIG scheduling. But if nothing else, this team needs to know about it.
Yes. I do see also parallels with when talking about multipod. I do see parallels with the implementation that is already there for topology we're scheduling in queue as well. So yeah, I'll also pull in the maintainers so that they can um, comment on the proposal. Mm,
Okay,
okay.
thank you. So right
So
now, this is alpha.
this didn't make it last release, right? So it got a
It
it
didn't
has
make
been
it.
merged
Everything I just
when.
described about the node selector, multi-node partitionable, none of that's in the cap right now. That's all something we've realized in the last month or so, is
Okay.
that we can use it for this. The cap is focused on subdivision of an individual node or individual GPUs, actually. So the two use cases, actually, the only use case described in the cap right now is the NVIDIA multi-instance GPU case, which is like take a single GPU, break it into smaller GPUs, and then schedule to those. Um, the other use case that's referenced in external documents, but hasn't the cap hasn't been updated yet, is what I mentioned earlier. If you have a Google TPU node with 8 TPUs, um, you might want to use two of them. Well, you can use TPU 0 and 1 or 0 and 2, but not 0 and 3 together. And so we can represent that. So those are captured without this additional node selector associated with each partition. The thing we want to change from what's written in the KEP today is add that, and then we can implement this other more um, snazzy use case.
Sounds good. If I remember correctly, last time the cap the enhancement was has been PR was merged and apparently didn't have enough input from API reviewers. So by the time of implementation, it got stalled because of API reviews.
Um,
So,
no, we just ran out of for partitionable devices. We ran out of we didn't have anybody to actually implement it. So it didn't get implemented. But the API, we can implement the API as it is. We might in the next 4 or 5 weeks make some tweaks to that API. But it's
mhm,
actually we've implemented quite a bit of it. We did get review from Tim. There are some taste issues in both of these first two first two caps listed. There's some
mhm,
API review revisions that may or may not happen over the next few weeks. That second one there, prioritized list, is owned by SIG scheduling.
mhm,
It looks like uh, it was in 132, but we didn't finish it. So that needs to be updated to 133. Um, and yeah, that's just SIG scheduling. Um, and alpha would be 133. Um, and that is actually implemented. We, though there is the way the API is as it's implemented, um, we may want to change, but what we would do would just be logically equivalent, but syntactically a little bit different for
mhm.
API review reasons. But we hope to get that actually. We can have that merged, the implementation merged before cap freeze. Actually, it's the
Uh,
implementation's already done.
when is
Because
kept freezing? Remind me.
cap freeze is February 13th. Well, it's not official yet, but that's the proposed date.
Okay, sounds
Uh,
good. So these are updates to the
yeah,
existing caps.
and so that second one for sure will need you or one of your other leads to opt in and milestone for us for 133 because it's owned by SIG scheduling. Um,
Mm, right.
yeah. Okay.
Oh,
And
wait, maybe I'm confused now. Why is this? I thought this was the same. This.
okay. First one is partitionable. That is currently SIG node owned, but probably should be SIG scheduling owned. Second one is prioritized alternatives. That one is the one you were just on, I think. That was opted in from 132, so I think that label was already on there, but it's milestone to 132, not 133.
Mm-hmm.
It should be in 133.
I
Um,
think
I,
I
I don't know if you can do that or the receipt release team has to do it. We'll find out. Um,
yeah, I have
you have the power.
permissions.
Um,
Um,
okay,
but
third one. This is pre-cap right now, but it will be squarely in SIG scheduling. And I'm not sure if we want to do it. Um, but if you think about the partitionable one, effectively creates heterogeneous nodes. So typically, our GPUs are homogeneous on a node. So a node has all the same type of GPU. However, once you can dynamically reconfigure the GPUs to be partitioned, then you effectively have a heterogeneous node. So if you come in and you say, I need a GPU with at least 8 gigs of memory, and that's your underspecified resource claim, the optimal way from a platform perspective to allocate that would be to find an 8 gigabyte partition, repartition the GPU to have that 8 gigabyte partition and give it to you because that's your requirement. I'm not going to give you an 80 gigabyte partition, 80 gigabyte GPU when all you need is 8. And so, um, but DRA is first fit. It doesn't have any scoring. And so what happens is if it evaluates the largest one first, it's going to give you the largest one, even though a smaller one would fit. So obviously, the first way to fix that is to make sure the first fit algorithm starts with smaller partitions and proceeds to larger ones. But what is smaller and larger? Like there's different resources. I mean, I think we can probably do that. But ultimately, users may have a preference um, beyond, they may have a soft preference, right? They may say, yeah, I need 8 gigabytes, but I would prefer it to be 8 gigabytes on a physical GPU, or I would prefer it to be 8 gigabytes with this um, generation, or I would whatever. Cluster administrators have a preference. The cloud provider may have a preference. So there's a bunch of different um, opinions as to which GPU and or partition of a GPU might get picked. We're talking about the scoring one now. So uh,
mm,
there's also it dovetails with the prioritized list one because well anyway it doesn't matter but I could go on for hours. So the point is I want to start this discussion. I don't know that we'll actually deliver anything in 133, but this is the team that is going to have a lot of um, opinions, and I wanted to raise it here and raise the awareness.
yes, yeah. My immediate thought is that it sounds like an extension of this.
It's not
Mhm.
exactly.
Mhm.
It's a slightly different thing because the first one alters the requirements. So in the first one, the prioritized list, I can say I would prefer to get a whole GPU, um, but of this of say I would prefer to get an A100 with 40 gigs. But you know what? I know those are hard to come by, so I'm willing to take you know two L4s or whatever it is that covers the same amount of memory, but um, but notice the difference is I went from 1 to 2.
Mhm.
That's different than scoring, which is evaluating. I mean, it's scoring of an option, so you could definitely, but you need a way to express that you need two, not just one, right? And so um, the prioritized list is more like we try and find the first one, and if we can't find it, we try and find the second one. Now, without scoring, and with homogeneous nodes, the prioritized list one is kind of crap because like you'll pick whatever node you land on, your priority list doesn't matter. Um, because your node is the priority list only gets evaluated once you've already picked a node. So in
Okay.
that sense, the scoring makes the prioritized list better when you only have homogeneous nodes. When you have non-homogeneous nodes, like in the partitionable case, then the prioritized list still has value because you could say, give me a full partition or give me two smaller partitions or whatever, right? It's complicated. I know like most people are probably like no idea what I'm talking about here, although you've been pretty talked with me a lot about these things. Maybe some folks do, I don't know. But it it's a lot of detail here I'm going into that people won't have the context on, but you get my point. They are all related
Mhm.
things, but they're slightly different.
Yep. Okay. Although realistically, these two items are already quite significant, so I doubt there will be time to make much progress on this.
Agreed. Yeah.
But
And then
also from a reviewer throughput point of view.
yeah,
Um,
I don't think we'd even like I my even my wildest ambitions we probably still don't deliver. You know, I'm always
mhm,
aggressive with these things, but I don't expect to actually deliver something for the third bullet. The last bullet is probably a scheduling thing. It's got to be a scheduling thing. And this is still very pre-alpha, like pre-cap formation. But here's the issue: is that DRA uses a different API to express your device requirements than the extended resources API. But we have a lot of code out there, a lot of manifests out there, a lot of workloads out there that are using the extended resources API. And
okay.
DRA is more expressive than the extended resources API. So you should be able to translate the extended resources API into a DRA request. And so that issue is for how do we do that? Can we make a migration path that is perfectly smooth? And there are two things there. One is for the user manifests. Yes, we definitely can. Where we get into trouble is it's easy to do if all the nodes switch to DRA. If you have a mixed set of nodes with DRA and device plugin, then it's harder because you don't know whether to do this translation until you've already picked the node. So it gets real tricky. So none of that's been discussed yet. None of that's I don't remember what Kevin put into his issue, but I don't think he went into that level of detail. So there's a bunch of open questions there that we need to resolve in the next month. But that's something we'd like. That's kind of to me. That's when we go back to the original topic of original things. I wanted to GA 134. This is something we need to figure out. A clean migration path before we can GA. And so I'd like to make progress on it in 133. Otherwise, even if we get something in 133, I'm not even sure if we can
Mm,
GA in 134 with the base. Probably we can because you don't need the migration path, but that's open for discussion.
In that case, I think the coda logic also needs to be changed, right? Because right now we treat it extended resource as regular resource, while the quota management is implement.
Yes, that is a very good point. The quota piece needs better, probably needs to be better addressed. So the current thinking is um, you would map an extended resource to a device class. So, and we do have quotas on device class. Uh, um, so in theory, that should be um, translatable, homologous. I don't know. Uh,
mhm.
um,
Is that the goal? Is to like give a grace period that is all the YAML manifest that are using extension resource can be implicitly migrated, and then upon our time, we just claim we are not supporting extended resource, and then just you have to use the DI as a class to express them. Is that the goal?
the no the extended resource API could live forever. There's no
Mm-hmm.
reason why it shouldn't. I mean, it has to. First of all, it's GA, but it's on a sort of driver by driver basis. Like if NVIDIA wants to continue to support it, then we need a mechanism by which when they're running the DR. So if you think about it, like there's different ways you could solve it, right? You could do something like the sort of like probably really bad way to solve it would be for the DRA driver to publish both the DRA resources and the device plugin extended resource. The problem is you'd end up with race conditions where people could claim between the two, like, and so which wouldn't get resolved until you get to the node. So that's probably a bad way to solve it, but that would work, right? I mean, roughly work. Um, the that's all in the driver then. Like Kubernetes needs to do nothing. If we want to solve it more smoothly than that, then one of the ideas I think that Kevin's proposing here is you could say, you know what, NVIDIA.com/GPU corresponds to this device class. So when somebody claims I want NVIDIA.com/GPU4, that just translates into a resource claim of this device class exact count 4. And so in that sense, right, it's DRA is sufficiently expressive to represent that. The question is, do you do that internally in the scheduler? Do you do that with a controller that actuates those? If it actuates those, then you can only land on DRA nodes. What if there's existing nodes that are running device plugin? Either one should be able to be to satisfy this requirement. So there's just a ton of questions we have to answer and figure out.
Yeah, I think another question is that do we have previous examples we can refer to see how we best follow existing pattern for this kind of migration? Do we have existing examples in the past history?
I don't know. Jordan's always my go-to for those kind of
Okay.
questions. Jordan or Tim, like, or David Eads, like what migrations have we done in the past where we take one API and we replace it with a different API that's more expressive, but both APIs need to live on? I don't know the answer to that question. It's a good question.
I have another concern. My usual concern is scheduling throughput. Because I mean, the array is significantly, it has a lot more steps, not a lot more steps, including additional API calls and waiting for changes in the API and so on. Whereas the device plugin is just internal counting by the scheduler,
Right.
and it just uses the single binding API request. So yeah, it will have to be comparable because we are dealing. I mean, especially because so far the array, from my understanding, has been focused on single pods, requirements from a single pod, but the extended resources are used by groups of pods, and those can come in numbers of thousands even. So any slight improvement in the throughput or in the latency would significantly affect these kind of workloads.
So you're saying I mean, the scheduler is pod by pod. When you say groups of pods, you're talking about in queue, or where are you talking about that happening?
No, I mean, they still pass through the scheduler. And the assumption is that the scheduling of each of the pods, once they have like a node selector or whatever,
I see what you're saying.
it is fast, right? It should be.
Yeah.
I mean, we today we are doing like 300 pods per second and so on. That's not uncommon. So that would be a significant challenge when using the DRA path.
Well, especially if we have to translate that into actual API objects, right?
Right. I think, well, there's a comment here saying that we would like to avoid creating those objects or something, right?
I don't remember. It's been since before the break, since like mid-December that I looked at this.
Yeah.
I
So
think
that would be a concern.
yeah, that's an important thing to raise. Okay, well, hopefully this has given you an idea of what we're working on. What do you think? Should we the first one? Do we move it to SIG scheduling, or do we just leave it where it is and make sure you all are approving?
Let's see the updates first, I guess.
Okay.
If the updates are significantly on scheduling, then we can move it. The rest is definitely all scheduling.
Yeah. Yeah. Awesome. Any other questions?
Okay.
So sorry, I joined late. So for I think yes, the latter three are pretty fitting SIG scheduling. So are we gonna to have some candidates to get the CAP implemented, and sorry, get the CAP crafted and get the implementation, or we try to find someone?
So actually, the first cap is already written. We have some edits we might want to make to it. We know we want to make to it. It's actually half implemented. The second cap is already implemented. All we're doing is waiting on some additional feedback on the API. We might tweak the API some. Cap's already like those were already, because those were both already queued up for 132. We just didn't make it. So 133, the second one's done. The first one's half done. The third one I don't expect to do. Like, I expect to more have discussions. Maybe we'll do something, but it's like such an enormous scope, honestly, when you really dig into it. And then the fourth one is just a concept right now. There's one other concept too that is like not even pre-cap. It's literally just a couple of bullet points.
I gotcha. Yeah.
That I didn't even discuss here. That's very much scheduling also, and it has to do with when you have a multi-node resource, like we're talking, like if you came late, you missed kind of a lot of the discussion on the first bullet. But what we're talking about is we already have multi-node resources within a resource claim that can span nodes. But when you have one, you might want to do secondary scheduling. All the pods you point at that still have scheduling questions that need to be answered, and so maybe it already works kind of, but we don't have it does because the scheduler kicks in. But the example is this: I have a resource that is accessible from 4 nodes. I have pods that I want to schedule to those nodes, and I point them at that resource that constrains them to those 4 nodes. That all works great. But then I actually want to do pod per node, which I can do today with anti-affinity, and it works. But so I guess maybe I don't know, there might be some other scheduling requirements in this sort of secondary, it becomes almost a secondary tier of scheduling. The other, I'm trying to think, there were some other examples, like GPUs that share are pods that share a GPU. Here's an example. So I create a resource claim that allocates a GPU. I schedule a pod to it. The way DRA works now, the actual allocation doesn't happen until a pod gets scheduled to it. That's fine. But it's configured for time sharing. Now I schedule another pod to it. I schedule another pod to it. That's all great, fine, and good. But I have no way of limiting and saying, you know what, when I allocated this GPU and I configured it for time sharing, I only want 8 pods to be able to attach to it. I don't have any way to express that right now in the API. It's just up to the user to only do 8. So I don't know if we want to do anything about that or not. Like maybe that's good enough. But that's one example of where you kind of have this common resource that's shared across many pods, and you might want to put some constraints on how it's consumed in that secondary scheduling step. And I don't know if we want to do that or not, but it's something I'm seeing in a few different cases. One was the one I just described. Another is this Google multi-node TPU slice thing. I might want to, I'm solving it right now with anti-affinity. It's fine, but like I don't know if there's other kinds of requirements. So I'm keeping an eye on that, I guess is what I would say. It's just an initial concept. One of the ways it's kind of related to something Kevin described six months or so ago, what he called linked claims, where you could sort of take a claim, you could potentially create a claim that represents a common group of resources, and then each individual pod would kind of create a claim against that claim, right? It's like a secondary claim. I don't know if it's a good idea or not. Just
Sounds a little complicated. So
yeah, exactly.
I do hope that the accelerator resources can be generalized like CPU. You can just burst, and it's if you want to time sharing or what kind of sharing, it's just sharing. And the underlying operating system or the driver knows how to do it, and they provide a generic API so that in the user side or in the Kubernetes component side, they are pretty easy to use the same consistent API to describe. But right now, we are not there. And you have to explicitly configure whether it's sharing or not, or etc.
You have to explicitly point pods at it. So that's right. What we have today, I refer to as user-mediated sharing. The user has to explicitly point the pods at it. I mean, it can be like you create a deployment, they all point to the same one. So every time the deployment scales, they share. But which is how we do some of these things. But we don't have platform-mediated sharing, meaning I can just say I need some GPU, and Kubernetes can allocate it to one that's set up to be shared. That doesn't work today because of the underlying sharing technologies aren't really quite sufficient. So we haven't bothered to implement that, I guess I could say. So. Okay, well, awesome. Thank you all for listening to me blabber on for 40 minutes. And I think we got some exciting stuff coming up.
Yes. Okay. So I'll make sure that the Q team is aware of all the proposals, because it affects it overlaps, and it might affect some of the things they're doing over there.
Okay.
But yeah, other than that, just ping us when there are updates to the caps.
Okay, sounds good. Thank you all.
Sounds good.
Thank you.
Yeah. Bye-bye.
Yeah, bye.